On September 1st, 1859, the sun nearly ended civilization. A massive explosion of energy raced toward Earth at 12 million miles per hour. When it arrived, telegraph systems across the planet caught fire. Operators were shocked unconscious. And the worst part? It could happen again tomorrow. In fact, scientists say it's not a question of if, it's when. This is the story of the most catastrophic threat we've never prepared for. To understand solar storms, we need to start with the sun. It's not just a giant ball of fire. It's a massive nuclear reactor constantly fusing hydrogen into helium. But here's the thing. The sun's surface is chaotic. Magnetic fields tangle, twist, and sometimes snap like rubber bands under tension. When they do, all that pent-up energy explodes outward in what we call a solar flare. On May 11th, 1859, British astronomer Richard Carrington was observing sunspots when he witnessed something extraordinary. A massive white light erupted on the sun's surface. It was the largest solar flare ever recorded. 2 days later, on September 1st, the effects reached Earth. The aurora was so bright, people in the Caribbean thought it was dawn. Telegraph operators reported their equipment catching fire. Some were knocked unconscious by electrical shocks. If this happened today, the economic impact would be catastrophic. Estimates range from $600 billion to over $2.6 trillion in damages. We came dangerously close to a repeat. On July 23, 2012, a massive coronal mass ejection erupted from the sun. Just 1 week earlier, Earth had been in that exact spot. If the timing had been slightly different, the CME would have hit us head-on. Fast forward to 2024, the European Space Agency decided to run the most extreme space weather exercise ever conducted. At their Mission Control Center in Darmstadt, Germany, scientists simulated a catastrophic solar storm, modeled after the Carrington Event. Phase 1, the flare. An X-class solar flare reaches Earth in just 8 minutes. It's so powerful that it disrupts radio communications instantly. Satellites lose their connection to ground control. GPS signals degrade. Air traffic control systems go haywire. Phase 2, the particle barrage. High-energy particles from the sun flood Earth's magnetosphere. These particles bombard satellites, causing false sensor readings, corrupting data, and damaging electronics. Spacecraft begin to fail. Phase 3, the coronal mass ejection. 15 hours after the initial flare, a massive cloud of plasma and magnetic fields arrives. It's so powerful that it swells Earth's upper atmosphere. The density increases dramatically, creating 400% more atmospheric drag. On the ground, transformers and power grids overload and fail. Entire regions go dark. Hospitals lose power. Water treatment plants shut down. Pipelines stop pumping. Navigation systems fail. Communication networks collapse. Emergency services can't coordinate. Supply chains break. Within hours, society begins to unravel. Satellites have shielding, but it's designed for normal solar radiation, not for the intense particle bombardment of a catastrophic storm. Once satellites start falling, they create debris, which creates collisions, which creates even more debris. A cascading chain reaction. The European Space Agency is building the Vigil mission, launching in 2031. Vigil will position itself at the L5 Lagrange point. From there, it will have a 12 to 24-hour advance warning of incoming solar storms. That extra time could be the difference between catastrophe and survival. Operators could shut down critical infrastructure. Its budget is €340 million, a small price for potentially saving trillions in infrastructure and countless lives. Scientists estimate there's roughly a 12% chance of a major solar storm hitting Earth in any given decade. The Carrington Event happened in 1859. We're now 165 years into a new cycle. The odds are ticking upward. The sun is beautiful and life-giving, but it's also powerful and unpredictable. The sun is beautiful and life-giving, but it's also powerful and unpredictable. We can't stop a solar storm, but we can prepare for one. The Vigil mission is a start. International cooperation on infrastructure hardening is another. And awareness, like this video, helps ensure that when the next big storm comes, we're ready. The question isn't whether it will happen. The question is, will we be prepared? Thanks for watching. If you found this mind-blowing, hit subscribe for more deep dives into the science that shapes our world.